Hello and welcome to exercise 5b, where we are going to look at factorising expressions. The previous section 5a we looked at expanding expressions, so this is we're effectively doing in reverse. So we'll start with a pretty simple thing that hopefully you've done before, or if you haven't, this will come pretty quickly. It's taking out common factors. Okay, it's the easiest and fastest way to factorise expressions. Take out the common factor, and you should always look to try and do this before you do anything else at all. Always try and look for a common factor first. At times you'll look at a question and go, oh, it's that type of question, but you might run into issues. It's because you haven't taken out the common factor first. So always look for common factor first, and it will put you in good stead for the rest of this subject and also going forward for year 11 and year 12 maths. So let's have a look. What we're looking for is a common term that we can, or common value that we can take out of both of our terms. So in this case, we have -4 times x plus 20. This can be written as -4 times x plus 4, 5. So in this case, we can actually take out this 4 as the common factor. So we might actually take out a -4 as a common factor. That gives us x. As we can think of using the distributive law in reverse, we'd multiply the 4 by the x. That gives us our first term. What do we need to plot? Multiply the -4 by the second term to get 20. Well, we know up here it's going to be 5, but we want positive 20, so we're going to make this -5. -4 times by -5 gives us positive 20. So we've just taken out the common factor of -4. Now, we don't want to just look for numerical factors. We need to look for pronumeral factors as well. In this case, we've got a 2 and a 4. That means we can take a 2 out of both of those. We have a x squared and y, and we have an x. That means we can take an x out as well. So let's take 2x out, and we want to think, okay, for the first term, what do I need to multiply by 2x to get 2x squared plus 2x squared y? I need to multiply by an x to get my x squared, and I need to multiply by a y. Now we look at my second term. Okay, what do I need to multiply 2x by to get -4x? Well, it's going to be -2, and I've just taken out one factor. Factorized as far as we can go. This one, you might be going, oh, we've seen this before. We need to do FOIL, expand. Let's do binomial expansion. Okay, but you want to look for the common factor first. You go 3 and y, there's no common factor there. But if we actually look at the binomial, x minus 2, that itself can be taken out as the common factor. So we'll take x minus 2 out as the common factor. And we can think, what do I need to multiply x minus 2 by to get 3? Or to get 3 by x minus 2? Well, I'm going to multiply it by 3. And then what? Just like this, we're in brackets, okay? What do I need to multiply x minus 2 by to get y bracket x minus 2? Well, I need to multiply it by y. So I do that, and that's my solution there. So I've taken the binomial out as the common factor, bracket, and if we did FOIL, we'd find that they are equal. So that's factorizing by using the common factor. Now, before in the previous video, we looked at the difference of perfect squares when we used it to expand. So we had a minus b, a plus b, and we found if we did FOIL, and we can do that quickly just to put, we've got a squared outside plus ab minus ab plus b squared. That then gives us a squared minus b squared. Okay? So we started with factorized form, and then we expanded, and we ended up with our expanded form. We're going to go reverse. We're going to use this reverse now. Okay? So we'll be factorizing instead of expanding. So we want to start with here. What are we looking for? What's the key that we're looking for? Well, we need a first term, all squared, subtract, and this is critical, we need subtract, okay? Subtract a second term, all squared. Let's have a look at this first one. We have x squared minus 36. Do I have a square of the first term? Yes, I do. Do I have a subtraction? Yes, I do. Do I have a second term all squared? Well, not at the moment, but we can turn pretty much always this last term into something squared. So let me show you. This is equal to x squared minus 36 can be written as 6 squared. Now, we are just like this. We have a first term squared, subtract second term squared. So we can write it straight away, we know, using our difference of perfect squares shortcut, we can write this as our first term minus our second term multiplied by our first term, add our second term. There we go, we have just factorized that. Let's go to the second one. This is looking good. We have a square, subtract a square. But 25 and 9, this square here is only affecting the b, this square here is only affecting the a. So can we rewrite this? Yes, we can. We could write this as 5a all squared minus 3b all squared. Step in between. Let's write that step in between because it's 5 squared, a squared, b squared, and we're using our index law. We're taking the squares out. It's almost a mini factorization self. Now we have first term all squared, subtract second term all squared. This is difference of perfect squares. So we can write it as our first term, subtract our second term, multiplied by our first term, add our second term. And we've just factorized it using our shortcut. 24t squared minus 54. Ooh, how do we do this? How do we do this? We can still write 24 in the form of a square. Doesn't look obvious straight away, but I'll show you how. Right now we can write 24. If we take the square root of it and square it, square root and the square cancel out. And now we have something squared minus, and we can do the exact same for 54. We take the square root of it and then square it, and that's equivalent to 54. So now we have first term squared, second term squared, and just to write it again, square root of 24, t all squared minus 4 squared. So we can now go first term, subtract our second term, close bracket, first term, add last term. Now we can also simplify these surds if possible. So for this one, this would be 64 into 2, 60 minus and 54. How can we do that? Let's see, that would 9 sixes. Yes, that would do 3 root 6 bracket root plus 6. And it would actually be helpful to simplify these surds first, so you're not having to put off first before you split it up into brackets. Looking at this second one, x plus 2 squared minus 9. We know how to expand this, so let's expand it, and then you could simplify from there and try and factorize. Or you recognize that it is first term, all squared, subtract second term, and we can turn this 9 into a square. We can turn that instead into a square. Let's do that, and we can still use our rule. So this is equal to x plus 2 squared minus 3 squared. We have first term squared, subtract the second term squared. So use our rule, we get 2, 3, 2, add 3. The reason I'm writing in these brackets, even though we don't need them at the moment, is that it's a good habit to be in to avoid sign errors, especially if this bracket, this binomial second term. And then we can simplify this to x, and then 2 subtract 3 is a minus 1. And then we get x plus 5. There we go. So that is factorising using difference of perfect squares. What are we looking for? We're looking for the first term, squared, subtraction, second term squared. If we get that, we can use it. Okay. As we saw here though in section C, sometimes you have to use a surd to get this to work. So this is an example of it. We had x squared minus 8. Well, there's not 8 isn't a perfect square, so we go square root of 8 squared. Split it using our difference of perfect squares and then third. Let's do b squared minus 12 squared to plus the square root of 12. That will give us, let's simplify the third, that 12 is the same as 4 times 3, so x 3. We can do the same here, we can do it with the fraction. That's fine, this is squared. Perfect squares, this is minus the 16. Using our third laws, and I'm going to put in a step here, so we might be able to skip this. Using our third laws, that's x minus 16, x plus 1 square root of 16. Square root of 16 is easy to simplify, so our final answer is root 7 4 x plus 4. So big thing here is we're looking for two terms with subtraction, and one of them is already a square. Now another way by factorising is by grouping, because we said at the very start we want to factorise by taking out the common factor. Sometimes you get a situation like this. Let's look at this one, x squared plus 3x plus ax. You're like, sweet, this is super easy, these first three terms. Okay, I've got a common factor of x, and you go, oh, plus 3a. That's no good. And that's my cat meowing. Well, if you can. So the problem is here we have three terms that we have a common factor, and then the fourth term that we don't. This generally occurs, the problems that you're given, generally going to be four-term problems. Problems designed because they always work out really nicely if you have four terms. What we're going to do is factorise in grouping, and like it says here, there's four terms. Okay, what we're going to do is think about splitting this into two individual problems. We're going to take out the common factor of these first two terms, take out the common factor of the second two terms, and then we'll see what's going to happen. So this is equal to x squared plus 3x. I can take out x, leaves x 3, and then I have my plus here where I'm splitting on ax plus 3a. Well, that means I can take out a common factor a, and I'm left with x plus 3. And you're like, oh, that's nice. And if you've been paying attention, 3x plus 3, that's a common factor. So just like this problem here, okay, we can use that as a common factor, take it out the front. Let's go to that. So it is equal to, take out our common factor out the front. What do we have? Multiply it to get this first term, we would multiply by x. To get this second term, we would multiply by a. And there we go. We have factorised this, even though there wasn't a common factor across all four terms, by just splitting into two, we could factorise. Let's apply it to the second one, ab plus 12 minus 3b minus 4a, okay? Ooh, that's not nice. AB plus 12, there's no common factor there. Negative 3b minus 4a, there's no common factor there. We could probably still do this by grouping, and what we're going to do is switch the order of our two middle terms. And most of the time, or if it's 100% of the time, but most of the time, four terms like this, and if you can't factorise by grouping, switch middle two terms. So we're going to write this as AB minus 3 plus 12 minus 4A. Now we can start taking out common factors. AB minus 3B, take out a common B, that leaves me with A minus 3 plus 12 minus 4A. That means I can take out a common factor of 3. So let's try and do that first. We're going to do, of 4, and that leaves us with 3 minus A. Ooh, not quite right. Close, we're close. We've got A minus 3 and then 3 minus A. These are not equivalent. They're very close, but they're not equivalent. What we have to do, try the eraser, but it might make the screen do the funny error again. Oh. No. Oh no. I apologize. I'll have to figure out how to fix that for future videos. What we're going to do, we took out a common factor of 4, but we ended up with 3 minus A, so the signs are incorrect. So what we're going to do, we're going to take out a common factor of -4. So that means we need -3 plus A. Okay. Now A minus 3, -3 plus A, we can write that as thing, and my god, this AY, my apologies. Okay, -4 is A minus 3. Now we have a common factor here, A minus 3 in brackets, so we can take that out. And then we have B subtract 4. Our solution. So to go over, if we have 4 terms and there's not a common factor across all 4 terms, look to split it into 2 terms and 2 terms. If you can't do that, switch to 2 and make. Here's an extension question and screen. Wonderful. Jump out of the slideshow quickly to try and. Okay. Sorry. Extension question. I would suggest pausing this video now. Give you about 5 seconds to pause, and then I'll start doing this. Yeah, pause it if you want to have a go yourself. Right here. Okay, so what we have here, we have 2x plus 3 all squared. So we can recognize this is the same as a plus b squared, which we know will give a plus 2ab plus b. Okay, so we can recognize that straight away. So this is 2x all squared plus 2 by 2x by 3y plus 3y squared. And I'm showing you all the steps just to clarify. Okay, I know some of you will be able to skip a bunch of these steps, but I just want to show the working for everyone. Okay, and this one over here exactly the same. Big thing to be careful about, it's a subtraction. So we're going to put the solution to this second binomial expansion all in brackets to make sure our sign operations are correct. So we get 3x squared plus 2 times by the first term times by the second term plus 5y squared. So let's start doing some expansion. We get 4x squared plus 2 times 2 is 4 times 3 is 12xy plus 9y squared. I'm going to put minus and keep this all in brackets first. So squared 2 times 3 times 5 is 30, and plus squared. Let's carry our negative sign now to expand out this bracket. So plus 12 plus 9y squared minus 9x squared minus 30 minus squared. Now we're going to collect like terms. So 4x squared minus 9x squared is negative 5x squared. 12xy minus 30xy will be negative 18xy. And then we have 9y squared minus 25y squared. That will be negative 15y squared. And that would be the solution. Factorize, we have factorized that, and then so there we go, and that is it for exercise 5b.